Right, during class, we're going to look at how to use Desmos to help us model one of these problems. So they're telling me the summer solstice and the winter solstice are these two numbers. That's the maximum numbers, hours of sunlight. That's the minimum. So if I find the average of those two, so I'm going to just put a fraction bar in there and average these. So I'm adding the max and min together divided by 2. That's the midline equation. So that's going to be the value of B here. So I got so something like that. I'm using W and O for omega and phi there, but B we just found was 12.016. Okay, now I can take the difference between these divided by 2, and that'll give me the value of A. So minus, so 3.54, that'll give me this value. And then for the others, I need the phase shift. So I need this omega will give me the period. The period is 365. That's the time between summer solstice. That's how many days there are in a year. So what I basically just said is this is the period, 365. So this is how we get the period. So swap this out. Put the W over here and the 365 in place of the W. And there is the value of W that goes in front of X. So now we've got that. And now we need to make sure that the maximum occurs on the 172nd day. All right, so let's graph it without this. All right, let's make this a 0 for right now, and then we'll see where we are. Okay, now I'm going to go from make the window go from 0, the 0th day of the year, to 365 days in a year. All right, I'm going to do a step size of, let's do 50, because we just need the graph more than anything. And then this is the minimum and maximum temperatures that we're given. So this is the hours of sunlight. So this is 8.4, so I'm just going to make it 8. And then this one was 15.56. I'm just going to make that 16. All right, and then we'll make that go up by 1. So there is our picture. Right now, this is taking place at 91.25. Right, that's the maximum. We need it to take place at 172. Right, we need that to be at 172. So what we're going to do here, I know this kind of seems a little bit weird. We're going to put parentheses around there, okay? And instead of 91.25, we need to subtract the number that's going to get us over here to 172. So 172 minus, again, the current number that it is 91.25. That's 80.75. So that's the number that would go right here. And now you can see that that's taking place at the 172nd day when we have our maximum number of hours. That's taking place that day when we have our minimum number of hours. Okay, so you can see that there's our maximum. There it happens again, and if you subtract those two numbers, 172 taken away from 537, you get 365. So that's a full year between the summer solstice. So that's what we're after. That's what we want. So that's our model. It's just we need to simplify this. So what I encourage you to do when you get to this part, you got to distribute this through. We got to get rid of these inner parentheses right here. So on this next line, I'm going to ignore the pi because it says leave your answers in terms of pi. Type an exact answer in terms of pi. So I'm going to leave the pi off. I'm going to multiply 2 over 365 times 80.75. Oops, not minus. Times, I'm going to click this button. It's going to give me this number. That is going to be a pi in the numerator and the 730 in the denominator. So I'm going to put that. I'm going to grab that number, put it right here. It's going to not be right for just a second, but if I put a pi right there, now it corrects it back to where it needs to be. So there is the model that we want to use here to plug in. All right, so there's all the numbers. I'm going to check my answer, and the big thing that you want to use here, the big thing that Desmos helps you with here more than a TI or anything else does, is this multiplication right here and giving you that fraction. I think Desmos is much better than a TI or any other piece of technology that you're allowed to use on your midterm and final at that. All right, use the function to predict the number of hours of sunlight on this particular day, the 91st day of the year. That's an x coordinate. So what you want to do on this is to type in x equals 91. That's the 91st day of the year. Okay, so I'm just typing x. That's what x models is, the day of the year, and the number of hours will be that y coordinate there. So 12.64 roughly to 2 decimal places. So 12.64 is the intersection of those two values. Okay, that's something again that you cannot do in a TI calculator that Desmos does allow for you to do. All right, the graphing tool. So I got some videos on here that will do that, but that will show you how to use the graphing tool. But in this case, we're using a sine function. So we have to start off with which of these is associated with the sine function. So this is cosine. You can kind of hover over and see it says cosine. This is sine, right? Because it's starting at the midline, going up and then down and then back to the midline. This is starting at the peak, falling and going back to the peak. So that's why it's cosine. This is sine. And since we're using a sine curve here, we're going to click that. Okay, so we're using that sine curve. All right, you just click in there anywhere. It doesn't matter where you start from. Just click in there. It wants to know what's your amplitude. My amplitude is 3.54. Wants to know what is my period. My period is, there's 365 days in a year, so 365. My vertical shift, that's what I always refer to as the midline, so that's the 12.016. And then my horizontal shift, that's the phase shift. That was that 80.75 that we started with, that we had in parentheses. That was the difference between the max, where it was when we had a 0 in there, and then where we needed it to be. But you can also get it from, once you have your model, taking the number right there beside the minus sign, dividing by the number in front of x. So that's 323 pi over 730 divided by the 2 pi over 365. That gives me that 80.75. It'll get you right back to that. That should be in your work somewhere anyway. But you can write it in there as the 80.75 if you want, rather than obviously those terrible fractions. All right, and then once you have that, save it, check your answer. There's your graph.